For this lesson, we're going to look at rational expressions and equations. The first topic we're going to look at is to simplify rational expressions. What you need to do is first factor out any numerators and denominators. And then you need to simplify, cancel out any common factors. So they can be numbers, binomials, trinomials, etc. So for the first example here, we can first factor out the numerator. So that would be 3x. And that's all we can do because the trinomial cannot be factored. And if we look at the denominator here, it can also be factored using the difference of cubes. Well, you haven't learned this yet, so this should be an additional part of the notes that you should add to your notes. And it would be good that you know this because it might show up in the near future. So I'm going to use the second one here. I'm going to rewrite 8 as 2 cubed so I can apply the difference of cubes. So x minus 2 will be my next factor. And I'm going to square x, multiply x and 2 together. The sign would be plus according to the pattern, and 2 squared will be 4. As you can see, you end up with a common factor, so we can cancel these two out. So your answer will be 3x over x minus 2. For this next one here, we have trinomials in both the numerator and denominator, and we need to factor each of them. So for the top, I can use 2, 4. 2 times 4 is 8, and I can also use positive 3 and negative 1. If you use the magic cross, it would be 12, negative 2, so this will produce a positive 10 here. So I'm going to leave this here for now, and I'm going to look at the bottom, 6 and 6. Then I can do 2, 3, 3, 2. So we cross this. This will be 4, 9, and this will be positive 13. Okay, and now we can factor 2x plus 3, 4x minus 1. Okay, so we have 2 common binomial factors, cancel, and then you have your simplified rational expression. And this next one here, we need a group. Okay, positive, negative, and group these. So I'm going to first factor out the numerators. So that would be x squared, x minus 5. I'm going to factor out the negative 3. So that would be x minus 5 as well. And then the denominator, I can do 3 and 5. Keep going. Cancel. And this is your simplified form because 3 is not a perfect square, so we can't use the difference of squares. Okay, now this next topic we're going to look at is multiplying and dividing rational expressions. So first we need to factor everything. And now we need to look for common binomial factors. So I see x minus 7, and that seems to be it. So now we have to put all your factors back together. So there's one common factor in the numerator, I'm sorry. So we can rewrite that as x minus 4 squared. So now this will be your answer. Okay, now let's look at a slightly more complicated one where you need to do lots of factoring before you cancel. Okay, now we're ready to cancel. And anything that's left, you have to put back together. And this is your simplified rational expression. Let's look at ones where you have to divide. So let's first factor. Okay, there's a lot going on. And then I'm gonna have to take the reciprocal. And I'm gonna also factor at the same time. Okay, now, common factors, x minus 5, and that seems to be it. So I'm gonna have to put everything together. Okay, x minus 3 over x times x plus 4 squared. Okay, now one more practice. As you can see, I am doing a lot of steps at a time. So I factored everything, and now I'm ready to cancel. I have x plus 4, x plus 7 can be canceled, and then whatever binomials are left are your factors. Just have to put them together. Okay, just don't forget any of these, okay? 6x for the denominator and x plus 8 times x minus 7 for the numerator. Now this third topic here is to add and subtract rational expressions. Now when you have like denominators, what you need to do is take a over c plus b over c and add the numerators and keep the denominator, just like how you would add a normal fraction. And the same thing goes for subtraction. And when you have unlike denominators, you need to find the LCD. And just like how you would add a normal fraction with unlike denominators, you need to combine the denominator so that it will be the same. Okay, so a over c plus b over d equals, and cd will be the LCD. And since the numerator does not have a factor of d, you need to multiply a factor of d. And the same goes for the other one. The numerator here does not have a factor of c, so you need to multiply by a factor of c. So now your denominators are the same, so this would equal to AD plus BC over CD. Now this may look very abstract right now, but it will become very handy once you start looking at how to add and subtract rational expressions. Okay, let's look at this first example here. Same denominator, so we can go ahead and just add the numerators. 5x plus 15 all over x plus 3. And I can factor out the 5 in the numerator, just like what we've been doing earlier. Simplifying rational expressions, and this would be 5. Now let's look at one where you have to subtract. Okay, at the top we could use difference of squares. Now this next one, we're going to be a little careful. We need to first factor the denominator here. Okay, so the next step I would write negative 15x, just to copy the numerator for the first term. And when you factor this, this would become, this is a perfect square trinomial, x minus 4 squared. And then I'm going to add this to 12 over x minus 4. And then, remember, when we're looking for the LCD, we want everything. And if the factor has the same base, we want the biggest power or exponent. Okay, since this fraction here has a denominator with everything, with 2 factors of x minus 4, then you can leave it that way. As for the next one, you need to multiply by another binomial of x minus 4 because we want to make the denominators the same, basically. So this will be 12x minus 48 over x minus 4 squared. Now let me backtrack a little bit. Think about simplifying these. If I cancel these out, it's back to normal. If I cancel, there's nothing to cancel out for the first one. Okay? And then now we could keep simplifying. Negative 15x plus 12x makes negative 3x, and then minus 48 all over x minus 4 squared. Factor out the negative 3, x minus or plus 16. And then simplify. Okay, for this next one, let's write the denominator as factors. Okay, now the LCM will be x plus 7 times x minus 2 because we want everything. And if there's any repeated ones, then we just take it one time. I'm going to skip some steps and write x plus 7 times x minus 2. Since this term has everything, all the factors in its denominator, we can just recopy the numerator at the top. But for this term, it doesn't have x minus 2, so I need to multiply x minus 2 to the numerator to combine these terms. Now I need to expand this part. So that'll be x squared plus x minus 6. And then I need to distribute the negative 1 in. So that'll be negative x squared minus x plus 6. I'm going to cancel negative x squared And then we can keep going with negative x plus 1 all over x plus 7 times x minus 2, and this will be your answer in simplest form. Okay, now let's look at some random challenge practice, and then the first one we're going to look at is simplifying complex fractions. So there's two ways to do this, and then I'm going to first show you the first way. And the first way is just to simplify the numerator and the denominator by itself first. So there's nothing to do to the numerator. I'm going to do simplify or add the denominator. So the LCD of the denominator here is x times x plus 1 because we want everything. And numerator 4 times x plus 6 times x plus 1. And I'm going to rewrite this as 16 over x minus 2 times, and we take the reciprocal, okay, it's divide, and then, so it's going to be x times x plus 1. I'm already taking the reciprocal, I skip some steps, okay. 4x, I'm going to distribute this in, 4x plus 6x plus 6. And then I'm going to add these together, so this will be 10x plus 6 I'm going to factor out the 2, and then I can simplify. So then your final answer will be 8x times x plus 1 all over x minus 2 times 5x plus 3. Okay, and now I'm going to show you a second method. But before I do so, I'm going to factor all the denominators within the bigger fraction. And the technique will be to multiply all the denominators within the bigger fraction by its LCD. So that would be x cubed, because between this factor and this factor, we want the one with the bigger exponent, and we also want this factor, x plus 1. I'm going to multiply this to the numerator, meaning all of this, as well as the denominator. So this will be canceled out, and my next step, I will get 3 minus 2x times x plus 1. And for this one, I will need to distribute. So 2 x's will be canceled out. I'll have 1 x left. 2x times x plus 1 minus, and for this one, x plus 1 will be canceled out, and one of the x's will be canceled out, so you're left with 1 x. And now we're ready to simplify. So I'm going to expand. Excuse me, I'm just going to leave this in factored form because we want to see if there's going to be any binomials we can cancel out. And the bottom I can distribute. So that I can combine these two. And this will produce 2x squared plus x. And then we need a factor. And your final answer should be this. We want everything to be left in factored form. Okay, let's look at a slightly more complicated, complex fraction. Now, before I move forward with this, I'm going to first factor out all these denominators, if possible. So the first one will be 3 times x plus 1, x minus 1, because after I factor out the 3, there's going to be a difference of square, x squared minus 1. And in this little fraction here, we just leave it as it is because there's nothing to do with the denominator. And the next one, we can factor this to be 1, 4. And then I'm going to use LCD method. So I'm going to multiply the numerator by 3 times x plus 1. We want every single factor. There's already a repeat, so just ignore it. Repeat, ignore it, and then x minus 4. And we'll do the same thing for the big denominator. And now we're ready to simplify. Now this has 3 factors to cancel out. So in the numerator, I'll be left with x minus 4, which is simple. Now the denominator is the tricky part. Okay, so this one I only cancel out x plus 1, which leaves me with 3 factors. I could multiply 5 and 3 together to get 15. And I'm going to write x minus 1, x minus 4. And in this one, I can cancel out x plus 1, x minus 4. And I'm left with minus 3 times x minus 1, x plus 4. Okay, and I'm going to factor out 3 x times x minus 1. Okay, and then I will get 5 times x minus 4. And then I'm left with minus x plus 4. Keep simplifying. Distribute the 5 and the negative 1. (5x minus x) 4x minus 24. Now we're not finished yet because we need to factor this out. We want everything to the simplest form. So I'm going to factor out the 4. So that makes 12. Be 6. And this is your final simplified form. Okay, let me first simplify this part of the complex fraction so we don't have to copy so many times. So 6 over, and the denominator, x over plus 2x. And then I can take the reciprocal of 1 plus 2x over x, which is 6 times x over 1 plus 2x. Okay, and then I can replace this with this part. Let's continue. Okay, I'm going to use the LCD to simplify. Okay, so that's going to be x squared, 2x minus 1, 1 plus 2x. And the same goes for the denominator. Okay, now that I'm going to start distributing this, cancel this out, so you're left with 3, 2x minus 1, 1 plus 2x, plus x squared, 1 plus 2x. And this one, we're going to take out 1 plus 2x, so we're left with 6x cubed, 2x minus 1. Plus again, cancel out 1x, and you're left with 1x, 3x, and the other two binomials. Okay, so this step is very tricky. And then I can factor this out. So it would be 1 plus 2x, 3, 2x minus 1 plus x squared. I'm not going to skip any steps yet, just in case I make a mistake. Well, here we have 2x minus 1. We can factor this out too. And we can also factor out 3x, because the GCF between these two monomials is 3x. So we have 2x squared. See, this is 6x cubed. And then this is factored out, so keep going. This part is factored out, so you're left with 1 plus 2x. Now we can simplify 6x minus 3 plus x squared all over 3x, 2x minus 1 times 2x squared plus 2x plus 1. Now I'm going to rewrite this more properly. So your final answer should look like this. 2x plus 1, okay, with the bigger degree first. So x squared plus 6x minus 3. And then we have 3x, 2x minus 1, 2x squared plus 2x plus 1. Now this is the answer.